We're all swimming in a sea of data, right? And we're constantly trying to find a signal in all that noise to figure out what's coming next. Well, you might be surprised to learn that one of the most powerful ways to do that starts with something incredibly simple: a straight line. I mean, it's the question we're always asking ourselves. What are sales going to look like next quarter? How is the market going to move? We're all trying to turn a gut feeling into a smart, educated guess. But how do we get beyond just guessing and start making predictions we can actually count on? And this isn't some abstract academic problem. We do this constantly. Businesses are trying to predict what you'll want to buy, economists are trying to model where the economy is headed, and scientists are looking for connections between things like education and how much you earn. It's a challenge that affects pretty much everyone. Now, you'd think that making these kinds of predictions would take some kind of mind-bendingly complex algorithm, right? Something that needs a supercomputer to run. And yeah, sometimes it does. But so often, the most powerful and useful answers come from a place of just beautiful simplicity. And that's really the secret here. The big idea behind one of the most important predictive tools ever created isn't about complexity at all. It's about clarity. It's about finding that one single perfect line that can slice right through the chaos and show you a pattern you couldn't see before. So this powerful idea has a name: linear regression. I know it sounds a little technical, maybe a little intimidating, but trust me, the concept itself is beautifully simple. So let's break down exactly how it works and why it's still so incredibly important, even today in the age of AI. So what is it? Okay, at its heart, linear regression is just a way to map out the relationship between different things. You take a whole bunch of data and you find the one single straight line that best fits through all those data points. And once you've got that line, you can use it to predict what's likely to happen next. And what's cool is how flexible it is. With simple linear regression, we can look at the relationship between just two things, say how many years of experience someone has and what their salary is. But we can also level up to multiple linear regression, where we start pulling in even more factors like experience and education and location to build a way richer, way more accurate prediction. Okay, so how does a computer actually find this perfect line? Let's get into the mechanics just a little bit. You'll be surprised at how intuitive the logic really is. So first, you need two kinds of players in this game. You've got your independent variable. That's the thing you use to make a prediction. You can think of it as the cause. And then you've got the dependent variable. That's the outcome you're trying to predict, the effect. Like the number of hours you study is the cause, and your final test score is the effect. The whole process is actually pretty straightforward. First, you gather up all your data, all those pairs of causes and effects. Then you plot them on a graph, and you get what's called a scatter plot. It just looks like a cloud of dots. Now here's the magic: finding the best fit line. The computer uses a method, usually called ordinary least squares, which basically tries out tons of different lines until it finds the one that has the smallest total error, meaning it's as close as it can possibly get to all of those dots at once. Once you have that line, you're ready to start predicting. So, okay, predicting a number is cool, but what does this tool actually tell us about the world around us? This is where it gets really interesting. What's absolutely incredible is just how essential this tool is. It's a true workhorse in so many different fields. Economists, social scientists, business analysts, they all lean on this to uncover the really important relationships hidden in their data. A lot of the time, it's the very first tool they grab when they get a new pile of information. And here it is. This is its superpower. It's easy to understand. A really complex AI model might give you an amazing prediction, but it often works like a black box. It can't really tell you why. Linear regression can. The slope of that best fit line tells you with incredible clarity, hey, if you increase your cause by 1, here's exactly how much we expect the effect to change. It's simple, it's clear, and it's so insightful. So with all the hype around artificial intelligence and deep learning and neural networks, you've got to be wondering, does this simple little line even matter anymore? And the answer is a huge, resounding yes. In fact, you could argue it's more important than ever. Think of it this way. Linear regression is like the trusted, reliable old guard, and these new, complex AI models are the sophisticated, powerful new kids on the block. But they aren't enemies. They're actually on the same team. The simple model sets a critical benchmark that the more complicated models have to prove they can beat.
It plays three absolutely crucial roles in any modern AI toolkit. First, it's your baseline. If your brand new, fancy AI can't make better predictions than a simple straight line, well, something is seriously wrong with it. Second, it helps prevent something called overfitting. That's a classic trap where a model just memorizes the data instead of actually learning the patterns. And finally, the core ideas behind it are the foundation for tons of more advanced methods.
So, bottom line, if you want to understand modern machine learning, you have to start right here. Linear regression is the conceptual bedrock. If you can really get your head around finding that best fit line, you're building the foundation you need to understand a whole universe of much more complex predictive models. Which kind of leaves us with this one fascinating thought. The world is just filled with data that, on the surface, looks like pure chaos. But if a simple, elegant tool like a straight line can cut right through that noise, reveal a clear pattern, and even help us predict the future, it just makes you wonder, doesn't it? What other, deeper patterns are out there, just waiting in plain sight for the right idea to come along and reveal them?